Hey folks, welcome to another episode of the Application Security Podcast. This is Chris Romeo, CEO and co-host of said podcast. I'm joined once again, as always, by my friend Robert Hurlbut. Hey Robert, how you doing?
Hey Chris, Robert Hurlbut here, threat modeling architect. Really excited about the topic today on encryption.
Encryption is one of those things where a lot of people are scared of this, and probably for good reason. But we're gonna unpack a little bit about why we need to be scared, maybe why we not need to be so scared. I don't know. But our guest today is Anastasiia Voitova. She has been on the podcast before. So the previous episode and interview that she did with us was on the topic of use cryptography, don't learn it, which I originally found Anastasiia because I saw this talk that she had done. I was looking at the slides, and that original title was kind of caught my attention. Like, wait a minute, use cryptography. We don't want to learn. I'm kind of a teacher at heart. I want people to learn about this stuff. But she makes a very compelling argument for why people need to use cryptography, but not necessarily understand all the depths that sit within it. So you can go back and listen to that episode. But today we're going to talk about something else. Robert, why don't you kick off our first question here to get us going?
Sure. So welcome, Anastasiia. First question is, what is end-to-end encryption? We've heard about it, but tell us about it. What is it?
Yeah, hi again. So our topic for today is cryptography again, right? And this previous time we discussed don't learn it, but today it looks like we are going deeper. Okay, so end-to-end encryption is one of the application layer encryption ways, right? Because encryption is just like an umbrella term, and there are different kind of encryption. We say TLS, which is data at motion encryption, right? We say data at rest encryption, like database encryption, for example. Both of them are encryption, but both of them are different types of protocols that use different types of ciphers to protect from different threats. So application level encryption means that application is responsible for encrypting and decrypting data, right? Application level encryption works together, obviously, with TLS and with database encryption, with basically any other encryption. It's just another layer of abstraction. When we are talking about end-to-end encryption, in most cases, this is just application level encryption, but done in a way that applications are communicating with encrypted data, right? So data is encrypted on the application side before it gets from the application. Technically, no matter what kind of application, technically we can say mobile application, we can say web application, right? It's important that the application encrypts the data before it sends through the network, through the servers, and the backend doesn't have decryption keys. So only target application can decrypt the data, building this end-to-end channel, which means that data goes from the source to destination being encrypted all the time. If this data is being processed by backend, that's fine, it's encrypted. If this data is being stored in a database, that's fine, it's already encrypted. If this data is appeared in our logs, our backups, sorry, it's encrypted, right? Often we talk about end-to-end encryption when we're talking about mobile applications, and in this, it's not only application itself, but the user as well, right? So often we link application layer encryption with the user as like a person and their trust anchor, password, biometrics, right? So the users are the ends, and the data got decrypted for this particular user. But of course, it's just one of the cases. We can talk about end-to-end encryption on the server level without any users involved, right? The main idea that only particular application can decrypt the data, which makes it really interesting from key management perspective, because obviously we need different kind of keys for encrypting and decrypting data, and most likely many end-to-end encryption protocols, they don't rely on symmetric encryption itself, right? Because symmetric encryption means like one key, secret key. And obviously when you want to build this channel, you don't want to have only one key. You want to have the key hierarchy. You want to have all this, nice and shiny key encryption key, data encryption key, customer customer master key, is it encrypts key, encryption key, yada, 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 yada. So this is where it gets interesting.
So I want to just summarize for a second and make sure that I understood. Here's how I'm thinking about this. Tell me if this is a correct kind of conclusion based on what you just described for end-to-end encryption. End-to-end encryption then provides data at rest and data in motion protection because the ability to encrypt and decrypt happens at the application layer. If that information gets passed through a backend, the backend can't decrypt it because it doesn't have the right keys. All the backend sees is a blob of ciphertext, crypto text, whatever that's in the backend. And so that's kind of a fascinating point for me that I never thought about, the fact that you could have data at rest and data in motion in the same sentence. So are these two things really happening at the same time?
Yes, absolutely. Imagine like a JSON model, right? Some JSON file, JSON like object with some fields. And let's say we want to encrypt email, right? So I'm building a mobile application to encrypt email field from my JSON model. I will encrypt only this particular field, right? So our JSON can be plain text, email is encrypted, plain text. And then I will send it to you. And you, for example, you have another mobile application. So this JSON, first of all, it will appear on our backend using TLS, right? So our email field is kind of twice encrypted, because first it was encrypted on my mobile phone, and then we use typical TLS, obviously, because everyone uses TLS, right? So technically we have two layers of encryption on the email field, right? Then, for example, it is stored in the database. And let's say we use some database, I don't know, let's put it in MongoDB, and let's use some data at rest encryption built in to the database, right? So another is like second layer of encryption. But even if we don't use TLS, even if we don't use data at rest encryption, we still have this email field encrypted until it comes to your mobile phone and you have keys to decrypt it. So yeah, application level encryption allows us to have data encrypted as long as we want if it goes through transit, data in motion. If it's stored, data at rest. At the same time, it means that we can still use all the things we use right now, right? So in some parts of our data flow, data gonna be twice, 3 times encrypted, and that's fine.
Yeah, I can see how that, for a modern web application, modern mobile application, how that really provides a lot of protection for our data and gives us a certain amount of assurance that our data hasn't been, hasn't had the, CIA kind of triad: confidentiality, integrity. I guess availability could still be messed with, but confidentiality and integrity are going to be intact because, you're at least encrypting once. Sometimes, and maybe that data may be encrypted twice, maybe encrypted 3 different times as it's making its way through your architecture. So, that makes sense to me as far as, and yeah, I'd never thought of it that way though. So you're expanding my mind here a little bit to think about there's a way to do more than just one of those properties.
I really like to think about it from threat modeling perspective, right? Because this application level encryption is like ultimate security control, right? Because it protects from threats during transit. It protects from different threats of data leakage, data loss during storage, right? It also protects from the threats with, I don't know, accidental like server misconfiguration, leaving S3 buckets in public, from leaking backups, from leaking this data in logs. So like application level encryption is like ultimate security controls that can like one shot to protect from different threats. But of course, it comes with a cost, right? We cannot say that, oh yeah, this is shiny thing. Yeah, it's shiny thing, but it's a costly thing. Because if data is encrypted all the time, it cannot be processed. I mean, we have encrypted email, right? It means that database doesn't have any encryption keys. We cannot search. through email field. Because it's encrypted, it's just a binary blob of something. Of course, if we use strong encryption, our binary blob is just gibberish, right? It's very complicated to brute force it, to try to understand, to do some frequency analysis. If we use strong encryption, our data is encrypted very well. Obviously, in a modern world, we have some techniques to solve search as well, because different searchable encryption approaches are possible. From ciphers perspective, like we can use different ciphers to decrease security guarantees, but increase ability to search through encrypted data. But at the same time, we can use modern approaches like blind indexing, for example, to make this email encrypted but searchable at the same time. I really am a big fan of application level encryption. I really think that soon, especially when our infrastructures, they have hundreds of microservices. So using nice encryption thing that gets data encrypted all the time, even when most of these microservices are vulnerable, it's a great idea. So having all these searchable encryption techniques is really our way to future.
So the S3 example of the bucket, a wide open bucket, is a great. It really resonates with me because that's one of those ones where it's, even today, if you create a new bucket on AWS, it comes with public turned off now. Like you specifically really have to jump through some hoops to make a bucket be world accessible, but yet they're still out there. They're still, people are still doing it, unfortunately, because it's a usability thing. You're like, no one's going to ever know about this particular bucket. But the fact that end-to-end encryption can solve that, because you're not worried about the privacy of it at that point. Like you could advertise that bucket as being available and tell people, come and get it, come and download whatever you want, as long as you've used a strong enough cipher, long enough key and stuff, as long as you're not using DES encryption or something on it, something crazy that people have been able to break. So that leads me to another question, though, that's a little bit off the script, I guess, but all of that sounds great, right? Like I'm with you so far. I'm tracking with you that, we should do end-to-end encryption for everything. There's got to be some downsides, though. Like it can't be, and you alluded to the fact that it can't be, if it was easy, everybody would do it.
Yeah.
And so what are the downsides, though? What are the challenges of end-to-end encryption? You mentioned searchability, but you kind of had some answers for that. But why would I not what's the pain that I'm bringing into my life by bringing end-to-end encryption into my architecture?
Yeah, so searchability is one of the most important ones, because again, this is a trade-off. Either we have nice security and resilience against frequency attacks, right? Or we have searchability, operationability, I would put it this way. Yeah, there are some ways to work around it, but still we right now fully homomorphic encryption is not here yet, so we cannot have all the wide range of data operations on encrypted data yet. So large minus. Another, performance. Obviously, when we do application level encryption, even if we selected only part of our data to be encrypted, right? Not the whole JSON model, but one field in the JSON model, we still add some, we still have these performance penalties. And so the most important one probably is key management, because encryption itself, it's very fast, it's very easy, encrypt the data, have plain text, now we have binary data, easy as that. Key management is a problem. With application level encryption, like with end-to-end encryption, I need, as one of the ends, I need keys to encrypt data, and you as another end need keys to decrypt data, right? So we need to get these keys from somewhere, we need to put it somewhere, we need to have a way, basically all these NIST guidelines on key management, key generation, rotation, revocation, expiration, sharing, yada yada. We need to build this. And one of my talks, I really like this topic because encryption is easy, as they say, key management is hard, because key management affects the UX of your system, right? Mm-hmm. It affects how you build these built-in calls, API calls in your application to get those keys. Do you store them on the backend? In this case, it might mean that this is not an honest end-to-end encryption. That backend still has some access to the keys, so not so honest. You know what I mean, right? So the trade-off is to build a system that gives good enough security guarantees, but it's not catastrophic in terms of all these additional layers we need to build to make key management also secure and usable.
So one more question before we transition to kind of more the UX, because I want to go in that direction. And I know Robert's got a question on that, but one more thing on the performance, just from your perspective as someone who is thinking about cryptography and is a cryptographer that's doing a lot of work in encryption. Like my iPhone 11, is it reached a point where the encryption operations are all being done in hardware and it's really not, it's not expensive then as an operation to do end-to-end encryption from the endpoint? Is that a fair statement?
Yeah. In most cases, like let's put like small asterisk there, but yeah, in most cases, encryption is really fast and cheap in terms of resources because most modern ciphers, when we're talking about symmetric encryption, IIS, right? IIS GCM, for example, it already has hardware acceleration for years for all the modern devices that we use. Right, so when we're talking about mobile applications, easy. Of course, with some caveats, of course, when we're talking about encrypting huge amount of data, yes, obviously it's gonna take some time. But when we're talking about chat applications, when we're talking about like working with this selective encryption, encrypting 1 field, 2 fields, 10 fields out of huge model, right? These are just bytes, kilobytes of data, small pieces. It's really fast and effective. Another idea is IoT devices, right? Small devices for like small specialized devices. Fortunately, we have ciphers that work for them. Yeah, iOS might be a bad solution for small stupid GPU, CPUs, right? But we have lightweight cryptography. We have a special ciphers designed to be stupid and work on these small devices. So yeah, encryption is really fast right now, especially comparing with all the languages, Python, Ruby, that we have on our backends, right? Comparing with all these huge monstrous infrastructures with microservices that make calls to another microservices that make calls to another microservice.
You mentioned about UX and some of the things that could affect it, like performance and so forth, and also mentioned honest end-to-end encryption. So I want to know a little bit about both of those more, about the UX as well as this term you mentioned, honest end-to-end. What does that? What do those mean, and how does that impact, for example, UX?
Yeah, because let's put it this way: like end-to-end encryption is a cool marketing term, right? You can see many applications we use end-to-end encryption because it sounds cool. At the same time, like honest end-to-end encryption, honest, I mean with all these honest ideas that only end applications or end users have access to encryption decryption keys. The all infrastructure in the middle, the all backend infrastructure, should not have access to decryption keys, right? So this is like the honest approach. Decryption keys only on the ends, only on these services that are target to this data, right? So it's very complicated to build because of the key management, because of this, the keys should be generated, keys should be put to the other side somehow securely, right? So usually we are talking about roping techniques, different roping techniques when encryption key is being roped with another encryption key. You know what I mean? And often applications, they combine typical client-server encryption and end-to-end encryption. One of them, like one of the great examples, is Telegram, which answers both questions about honest encryption and UX. You can see if you have used Telegram before, you see that they market a lot that they are super secure messenger, right? At the same time, they state in their docs that they use typical client-side encryption for chats and for channels. Client side means that the data is encrypted on mobile side, yes, but gets decrypted on a backend by design, right? And this typical client-side encryption will cover like 90% of all the features in Telegram. They use end-to-end encryption only in a very, very narrow use case, in special secret chats. Secret chat that you create as a user from your mobile phone, because only mobile applications support that. You create the secret chat to another user on their phone, and this secret chat is like, it's like peer-to-peer in a sense. It goes through this exact installation of this exact application of this exact user. Data gets encrypted there, and data gets encrypted on this exact installation, exact device of the second user, right? And Telegram, they kind of combine this typical client-side encryption for most use cases, for most users, and this very special end-to-end encryption for paranoid users with better security guaranteed. And these secret chats, if you use them before, Signal, by the way, Signal does the same in terms of secret chats. They show you all these notifications like be aware that this user has this public key. It's your responsibility to check their public key. You know, they increase the security like guarantees, but at the same time, they make UX more complicated for typical user, for not security aware user, because of all this check the keys, make sure that this chat is only synced between two devices and that's all, so you won't have a copy of this chat in your desktop, right? And many applications, so yeah, my point here is that end-to-end encryption is complicated in terms of key management. So many applications use hybrid approach. Even when they market as end-to-end encryption, they can use typical client-server encryption for most cases and end-to-end encryption for narrow cases, because it affects UX, it affects like user perception of what users need to do.
Does that mean that those, from what you're kind of describing here, like, should we be less trusting or less positive on these, I'm going to put in air quotes, secure messaging apps? Like, should we be more concerned about them based on this? Like, because I didn't know this. I would have, if you would have asked me before the interview started, hey, Telegram, Signal, all these types of things, like, are they doing end-to-end encryption so that people, the back end is not decrypting and not knowing what's happening? I would have said yes, but I think I would have been naive in my answer by saying yes. So does that mean, do you trust these messaging apps less because of their architecture?
Well, it depends on how much they say us, right? Telegram has this in docs. So technically, they can say we're using end-to-end encryption because they do, but for narrow use case. I did a comparison of Telegram, Signal, and WhatsApp, and from my perspective, Signal is the most kind of trusted one because they communicate in docs exactly what they do, right? They have these end-to-end encryption flows all the time. WhatsApp, again, from my very opinionated take, is the most questionable one, right? Because end-to-end encryption, even when application uses end-to-end encryption, it doesn't mean that all your data is like private, because security, privacy, and encryption are three different things, right? So imagine that, yeah, for example, let's say that WhatsApp uses end-to-end encryption everywhere, but they can still grab your data, sell it elsewhere before encrypting, right? Using end-to-end encryption itself, having this like encrypt line in code, doesn't mean that the data is being encrypted instantly. The data can be first analyzed, stored somewhere, put into some analytics before encryption, right? So privacy and encryption are different things. Again, application can have really good security in terms of what we understand from good security right now in terms of WASP guidelines. At the same time, application can have really good privacy, but no encryption, like no end-to-end encryption at all. That's fine, right? Three different things: security, privacy, and encryption. Like combined, select two,
Mm-hmm. Yeah, I mean, Signal's been my go-to as a messaging app for the reasons that you described. Like, just by reading what they advertise as far as what they do, it seems like they're the most transparent amongst all of the messaging apps. But now I'm realizing that now that you've explained architecturally, that's also a better it's a better choice because they're, once again, transparent, but also using the end-to-end encryption approach more clearly than either of the other messaging providers that are out there.
Yeah, and as Signal user, you can feel the UX penalty, right? Because if you tried using Signal desktop application, for example, you can use mobile application and desktop application. Their desktop application, it's not a standalone application. It should be linked to your mobile app. So mobile app is a source of truth, right? And this like they have this linking process where you need to scan a QR code, yada yada. They have all this limitation how many desktop application you can have simultaneously. So this is like a UX penalty for using end-to-end encryption, because they cannot provide you a freedom of installing 5 applications but still have an end-to-end encryption. That's very complicated.
But those are some of the trade-offs, right? And
Yeah.
that kind of goes back to application design and UX and
Absolutely.
so forth.
Yeah.
The various trade-offs. Once you decide what's my privacy solution, my security solution, encryption solution, and so on, and still trying to build an app that's usable and secure and so forth. But those are all trade-offs, and it sounds like, it's good to know a little bit about some of the others. I don't know if we were planning to do that in this podcast, but it's pretty cool to hear about some of the differences. But again, trade-offs. We all are thinking about trade-offs when we're building apps, and how do we make them security versus usability, privacy, and so forth, that we have to think about.
Absolutely. Another trade-off into this collection from end-to-end perspective is engineering amounts, like engineering efforts and UX, right? So we can make user life easier, improve UX, but make our life as software engineers hard, because we need to build this really multi-layered system, to keep in mind all these use cases and corner cases. And this is what I often deal with when designing encryption layers, because the easier you want to do system for user, usually the more complicated it's going to be for developers, for engineers to build and then maintain, support, and all the things. So yeah, trade-offs everywhere.
Yeah, the maintenance and support are some of the most challenging pieces of that, because when you're thinking and designing and building something the first time, you're understanding how all the pieces come together. The challenge is like 12 months from now when someone gets a bug and they're going to like, why are there 7 layers of encryption things happening here? And I don't know what's happening in any of them. And then they have to relearn it, to be able to support it. So, keep it simple is always a good design principle I don't care what you're designing. If it's a swimming pool or an end-to-end encryption, keep it simple, because if you make it complicated, no one's going to be able to figure out what it actually does. And that, I guess, in some regards could be more secure if nobody can figure it out, but somebody will figure it out somewhere on Earth.
That's why typical end-to-end encryption protocols are so complicated. If you ever read the description of double ratchet end-to-end encryption protocol behind Signal, right? Signal protocol. It's very complicated. The key, not like very, but quite complicated. The key management, they have different steps of key management itself, right? Before even the encryption, and they need to build in all this protection against replay attacks, for example. So yeah, a lot of trade-offs. Security engineers often try to make security systems as easy as possible, but real life is still here with all the threats we have. And every time we need to make this decision if we want to protect our system against these threats, and how much it will cost for us as engineers, and how much pain we will add into people's life,
Yeah, so I guess from a key takeaway or call to action perspective, what would you like our audience to do as a result of this? From your perspective, is there something they can go study? Is there something they can go watch? Is there some action, something they can go do to make the world a more secure place with end-to-end encryption?
Absolutely. So if you ever see, Jira ticket, that says, let's add encryption here, and it's estimated like 3 hours, it will never be 3 hours. Okay, so the most important key takeaway is that encryption, it's not just an encryption. It's the whole system of deciding what data to encrypt, which cipher to use, what library to use, how key management should look like, and what the trade-offs that we will make in our system, security, usability, development efforts, yada yada. So encryption is never encryption. So if you want to build anything with encryption related, beware. Probably, most likely, there are already ready solutions, or building blocks, or open source libraries that can make your life easier. Or go talk with people who who build encryption based systems, just because probably you don't right now understand how deep this abyss is.
Well, thank you so much, Anastasiia, for joining us again on the podcast. And, I know you expanded my mind. I'm sure Robert's going to agree as well. Like you expanded my mind in a lot of different ways about encryption that I just hadn't thought about before. But I love this idea of end-to-end encryption. I love the idea of it being a user layer thing where it doesn't matter who can see it on the back end, doesn't matter what nation state gets access to it. It's not available for them. Even if it traverses their country and sits on a server in their country, they can't unlock it. And that's a very powerful thing that I think as we move towards a more secure and more private world and a more secure and private internet, these are going to be this is going to be one of the building blocks that a lot of things have to be built upon, this whole idea of end to end. So once again, thank you so much for being here with us, and we look forward to another conversation in the future where you teach me a whole lot more about cryptography and encryption. So thank you very much.
My pleasure. Thank you for having me.